So this is just a basic, simple agenda, and showing you a little bit about my work with polars and integrating it with some simple Plotly visualizations. For the last 6 weeks or so, I've been participating in Adam's Figure Friday program. It's a great experience for sharing and reviewing visualizations from others. We use publicly available data, so there's no confidentiality things to worry about. And I've learned so much for it. Thank you, Adam, for setting up that program, and everybody who's involved in it for being so kind and helpful. And I try to reciprocate. But let's start with the overview. You've probably seen charts like this that compare pandas and polars. This is one that was released less than a month ago. You know, the key point is that polars has been around since 2020. It's much newer than pandas, and you can see it's on a very impressive growth trajectory. Does that mean you need to learn polars? No. You can stick with pandas. I'm okay with either one, and I really don't want to try and seem like I'm trying to advocate or sell for polars, but it's just my own experience. So I read a book by Matt Harrison. He's one of my favorite authors. I've read his books on effective pandas and other data visualizations, and I got his book Effective Polars as well. And in the foreword of that book, there's a paragraph written by Marco Gurelli, one of the developers of polars, that says, came for the speed and stayed for the syntax. And I can't think of a better paradigm from my experience than that phrase. So I was seeing benchmarks where polars was coming out 10x faster than pandas in many use cases, although not all of them. But the speed was so impressive. And I was looking for something that would make my work more productive. So instead of waiting minutes for something to happen, it could be done in seconds. And I realized that. And you don't have to be a great polars coder to get those benefits. So that was a benefit right off the top. And then I started seeing the syntax is really more intuitive, because I'm not a software engineer. I don't do this stuff, like I said, every day. So like other people, you know, we're always looking for how to do this, how to do that. I just find it easier to get done what I have to get done in polars than the equivalent in pandas. But it does have a learning curve here. You won't convert to it overnight, but there are some things that can make your transition easier. A few benefits that may spark some people. There's no indexes. You know, set index, reset index, all those things, or column not found because you're trying to get a column that is the index. You probably experienced that. You don't have that kind of complexity. And why shouldn't your DataFrame library manage that for you? Why do you have to do that? Have you ever have your integer column gets converted to a float because of the missing data? You know, you don't have that happen. They have much better handling of missing values. There's horizontal computations like sum horizontal. You know, there's just a few general comments, but you find a lot of things in the syntax that to me are very, very welcoming over pandas. And I'll give you a few examples, but let's see where we are in the state of the art here. The polars version currently is 1.5. The first production version was released a little over a month ago, 1.0. Some people don't like to use tools that are not, you know, at 1.0 or later. Plotly, as far as I know, is 5.23. The Plotly Express started supporting polars directly a little bit over a year ago. So Plotly sure has a lot of experience with polars, data frames, converted to visualizations. And in the earlier days, well, it still does. Polars has 2 APIs that will convert a data frame to pandas or read in a pandas data frame. So I had a use case where I had like a 10-step flow, and I wanted to convert everything to polars. And as I debugged each step that was pandas into polars, when I found a few really difficult and I couldn't get them done quickly, I said, okay, I'll do this one in pandas and then go back to polars for the rest of the flow. That's not an optimal way for a final solution, but it gets things going. And so let me start with some examples. This one hits you right off the top, right off the bat. You do head or tail to see your data frame or sample. Polars gives you this beautiful display that has the actual data type right below every column name. That's really useful. I mean, this could save you like, 2 or 3 steps that you're normally doing in the pandas world. And by the way, this is data from the US presidential election data set that was from Figure Friday a few weeks back. There's another tool. I really love this one so much. And it looks like just a bunch of alpha soup, but this is called Glimpse. And it's similar to head or tail, but it transposes your data frame. And let's say you have like 100 columns or a really large number of columns. If you ever use head and you have to scroll left and right, it's kind of tedious. It's hard to find what you're looking for. So Glimpse gives you a transposed view as a text representation for the first, n rows of your data frame. It has the column names and the column types. You could easily like copy and paste this and dump it off into a text file. It's really, really useful. I would be surprised if pandas were to develop these, because these are no super technological achievement, just things that somebody thought of putting into polars. Maybe pandas will adopt them as well. This is an example of column selection. So I've listed 4 columns to show as a data frame, right? No big deal. In pandas, you would have said df all with bracket, bracket, then your column names, and then close with bracket, bracket. Same thing, no difference, right? This is a little bit more expressive. There's more things to type. Some people don't really like that aspect too much. It doesn't bother me though, because it jumps off the page what I'm doing here. I'm selecting a subset of columns in a data set that has more columns than shown. You can select columns by expression. In this case, I have selected all of the string columns. You can see all these data types are strings. And I gave it an exclude column, just show the capability. So I said leave out the simplified party. I probably want to exclude the notes column because there's no useful information in there, but you get the idea. The polars expressions are very very well liked by this community. So those are some simple use cases from our Figure Friday group. And continuing on, I took the data set of US presidential elections and wrote a small little flow to give me this table on the right. So you can follow this through. There's a filter step where you're selecting the values you'll accept from the simplified party category. And notice the is underscore in. Pandas uses is in without the underscore. You come across these minor differences in wording. They're kind of interesting. This is a group by, so it says take, the party and year and sum up the candidate votes. So for every party and year, this number equals the number of votes for all 50 states plus Washington, D.C. That's pretty simple. This is sorting the values. So the year in order by year. Notice this descending equals false. Pandas would be ascending equals true. It's an interesting difference in the syntax, why they pick different words that are inverses of each other, but it's okay. And then a simple pivot, a pivot on the year and on party simplified, so the parties become the columns, and now you have your beautiful table. So just a very straightforward use case. Something you can easily do in pandas or polars. So I'm just trying to show you a little bit of the wording we do specifically. And then you say, this is a great table, but I don't want to look at these tedious numbers. Show me who won the election each year. So I can go and add a column, and this code is the same as the previous slide up to the with columns column. So I added a column called winning party. And this looks like a wordy kind of syntax. Pandas will be far fewer characters, but it's pretty easy to follow along. When, then, otherwise is more or less if, then, else in other languages. But when the Republican vote total is greater than the Democratic vote total, it says use PLLit Republican, which means literally add this string Republican, not values from a column, but add the word Republican to this column. Otherwise, add the word Democrat. And so, I find this kind of syntax a little bit easier. And can anybody see anything wrong with this table, by the way?
What's the question again, Mike?
Does anybody see anything wrong with this table? Any error?
Let me see.
I'll give you the end. Don't worry. The winning party in the United States elections is not necessarily the candidate or party that gets the most votes. There's the electoral college system. So in this table says the Democratic Party won in 2000 and 2016, and the Democratic Party did indeed earn more votes than the Republicans, but the Republicans won the election based on higher total number of electoral college votes. In the Figure Friday example, I did this a little bit differently. I kind of hand-coded a table with the winners because you can't really determine the winner just by counting the total number of votes nationwide. Anyway, that's always an interesting case in data. You think there's exceptions that got to be considered. Anyway, now this is the only slide I'm going to cover with some optimizations, but I won't go too much in the weeds on this. Because I'm the kind of person, when I buy a new car, I want to test drive it and, feel the road and how comfortable everything is. I could care less what's going on under the hood, and this is a little bit under the hood, but they have two types of data structures in polars. One is called a data frame, just like pandas, and the other is called a lazy frame. And what I've created here in this block, and I don't have the whole block shown, but this is a lazy frame. And what does a lazy frame do? A lazy frame is really like a query recipe. So when this code is parsed, nothing is actually executed. It's just kind of compiled into a query recipe. And what you would see at the bottom of this, if I show the whole thing, would be there's a statement called collect. And when it hits the collect, it takes this recipe that's compiled, and then it runs the full query. But it does this optimization, like it knows if you have columns that aren't used, it doesn't request those columns. If there's things it can do with your filtering. Like in this example, I created a percentage difference and then the absolute value of the percent difference. The query would know whether it really needs to run both of these or merge them and combine them. So it can give you a big speed advantage. I haven't really paid much attention to this stuff, except I try to use lazy frames when I can. I haven't been measuring the time so closely, but this will get you really, really high speed performance. Okay, this is prep and polars for Plotly. And let me give you a spoiler here. There's not much of a there because Plotly just works with polars. And so I put this in just for academic sake, I guess, but I created this data frame in polars. This syntax is pretty much the same as what you would do in pandas. This is just like 3 columns with list comprehensions to make a trigonometry table of sine and cosine 0 to 360. This area highlighted in yellow, this is a polar specific syntax. I wanted to, I didn't want to show like 10 digits of information when 3 is enough and it's clear. So I told it to just round these columns to 3 digits. Pretty simple. And that's kind of it. The real story, though, about prepping for polars is, you know, every polars visualization expects a certain data frame structure, like how you align your X and Y columns and different things, right? I mean, you always have to clean your data frame in preparation for Plotly visualization. But the rules are the same whether you're in pandas or polars. So you can take this data frame, and in this case, I just typed it into a PX line. I said the data frame name. The X column is the first parameter. This list slicing says all the other columns will be plotted as Y values. And then basic stuff. There's no real difference. So really, hats off to polars for making this journey so easy to use. And for people like me who, I mean, Plotly is clearly my favorite data visualization tool, and there is no close second. It's so nice that this transition is pretty seamless. So I don't have much to say about this slide, but really there is nothing you really have to do special in polars that you wouldn't have had to do in pandas to prepare your data frames. And if you must, you can use to pandas or from pandas to convert back and forth. Those are really handy when you're learning polars. And I won't go into this detail, but polars has a really powerful list data type where your data frame cell is actually a list of values. We can maybe talk about that some other time, but that is unique to polars. I don't think pandas has that sort of capability. In pandas, if you have a list in a cell, it's treated as a string, the whole, the bracket and all the elements in it. So let me go ahead and wrap this up. And I started by saying how, Marco Gorelli on polars came for the speed and stayed for the syntax. And I just want to say, I have a similar comment about Plotly. I really came because I saw interactive visualizations that I could save in HTML files and share with colleagues. And some of the 3D stuff is really, really impressive. It's just so powerful. And so I thought, okay, this is good. I can use Matplotlib for my static stuff and Plotly for the interactive, right? But actually speaking, these days I'm using Plotly for pretty much anything, even stuff that could be done very nicely with Matplotlib or other tools. I find the Plotly visualizations are superior. Sometimes I share a screenshot. It's just a screenshot, right? It's not interactive. So I'm quite good with what Plotly does, even when in a non-interactive context. And let me say, this Plotly community that has been set up by Adam, maybe it was before him, but the community website and the Figure Friday that really gets people speaking to each other and helping each other. And I can say that in 6 weeks I've been on this Plotly Figure Friday, my skill has really grown so much. And you just stumble on little things like, you didn't know it, and you try things out, you take risks. It's a really great community. This is the end of my talk, but I'll take any questions and really appreciate everybody for listening and Adam for hosting us. Thank you.